Alright guys, so the final way that we can prove two triangles congruent is called HL, which stands for hypotenuse leg. Now I want you to recall that a hypotenuse sits across from the right angle. So if I make a right triangle of any type, let's just say here, okay, this right here is my right angle, which means the side directly opposite of it is my hypotenuse. So there, this right here is my hypotenuse, okay? So just as a refresher on that. Now, in order to prove two triangles congruent, you need to have the hypothesis of both and one pair of legs, okay? So this whole statement right here actually belongs inside of your box, okay? So take a minute and write that down, and then we'll discuss. Alright, so looking at the pictures, you'll see that I have the hypotenuse is congruent to the other hypotenuse. I have that one leg is congruent to the other leg, and I also have a 90-degree angle. Now, a 90-degree angle is given because you need to have a hypotenuse. Remember, the hypotenuse sits directly opposite of the right angle. So because I know that BC equals EF, and AC is congruent to DF, and then I can say that the two triangles are congruent by HL. Alright, so we have two triangles here. We need to prove whether or not these two triangles are congruent, okay? Alright, now I have drawn two separate triangles here. Notice that it looks very similar to the picture on the left. What I'm going to do is I'm actually going to drag this second triangle away. And we're going to go ahead and label. So the first triangle is RTV, and the other triangle is STV. Okay, I'm also given in the picture that RV is congruent to ST, that angle T is a right angle, and angle V is a right angle. So what's probably going to happen here is it's probably going to be HL, but right now I have that the hypotenuses are equal to each other, but I don't have a pair of legs. Can you see that TV is shared in both? That's because of the reflexive property. I can say that TV is equal to TV, therefore the two triangles must be congruent by HL. So let's go ahead and write a two-column proof. I've first been given that RV is congruent to ST. Alright, so that is given. Number two, angle T is congruent to angle V. That's right angles. Let's say definition of right angles. How about that? Alright, I also know that TV is congruent to TV, and that would be the reflexive property. Alright, now we can say that the two triangles are therefore congruent by HL. Remember that naming the triangles is very important. Triangle RVT is congruent to STV. So let's see. R is corresponding to S, yes. T corresponds to V, yes. And V to T. Okay, very good. And we need to state by the HL congruence postulate. Alright, let's take a look here. Notice that I have at the top of this page, they could be anything. Side, 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 angle, 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 side, hypotenuse leg, or even none. There could be no congruence at all. So it's our job to simply just determine which of the following methods could prove it. So I'd like you to pause and try problems number 2 and number 3 right now. Alright, so in this problem, I currently have one pair of congruent sides. I also have one pair of congruent angles. I need another piece of information. I either need another angle or another pair of sides. I can see that this middle line is shared by both triangles, so it's congruent to itself by the reflexive property. So now I have two pairs of sides and one pair of angles. So the question is, what am I? Okay. First off, I need to check. I have two choices. I can either be side angle side or I can be none. You have to look. Is the angle included in between the two sides? And it is. So for number 2, we can prove these two triangles congruent by side angle side. On number 3, we see that these two angles are vertical angles and are therefore congruent. So I have one pair of congruent angles and two pairs of congruent sides. So I can either again be side angle side or none. And the question is the angle included in between the two sides? And it's not, because this angle is the included angle, and I'm not given that. So the answer here will be none. Okay, now some of you will try to make the mistake of saying angle, side, side. Okay, just be aware, angle, side, side is not something we do in math. Okay, so just remember, you don't swear in math. Okay? Alright, 4 and 5 have the same directions. Please give them a shot. Pause. Alright, so taking a look here, I see that this side is shared by both triangles. Now, we can't do angle, side, side. Remember, you can't cuss in math. However, there is a right angle, which means that they both share a hypotenuse. So this would be HL. The hypotenuse is the same for both triangles, and they have a leg of equal length. Number 5 also has a shared side. So this time I have two pairs of angles and a pair of sides. So I would either be angle, angle, side, or angle, side, angle. The question is the side included or not? Since the side is directly in between the two angles, it is included, therefore it is angle, side, angle. Alright, number 6. Go ahead, pause, and try this here. In number 6, we have a pair of vertical angles. So I have two pairs of angles and one pair of side. Okay, I can either be angle, angle, side, or angle, side, angle, or again, it could be none. Alright, so let's do this check, okay? Is the side included in between the two angles? Alright, here are the two angles. The side that is included, meaning between them, is this side right here. We don't know anything about that side, therefore it has to be angle, angle, side. On number 7, they share this middle diagonal here, and because I have three pairs of congruent sides, I can only be side, side, side. Now, occasionally you'll come across a problem like this, and they're asking you, what can you do to make these two triangles congruent? What piece is actually missing? So what we have here is I want to prove these two triangles by side, angle, side. Notice I already have two pairs of sides. I've got that taken care of. I need to take care of the angle, however. Now, this angle is included between the two sides. So take a look at triangle ABC. Which angle do you think is included, meaning between line AC and line BC? If you said angle C, that is correct. Angle C is in between line CA and BC. Notice that I said the word C twice. That is the only angle that touches both lines. So going over here to DEF, that means angle D is your included angle. So the answer here that we're looking for is we need to know that angle C is congruent to angle D, and then I can prove these two triangles congruent by side, angle, side. So this is the additional information you needed to know, that angle C is congruent to angle D. Alright, hey guys, I wanted to introduce you to my other cat. This is Luke Skywalker. As you can see, he's very interested in this treat that I have in my hand. As you can see, he is a wonderful orange tabby cat, and yes, he does follow the Star Wars theme. So this is my little kitty cat. Can you say hey, Luke? Hi. Like I said, he's more interested in the treat than he is you guys. But just remember, sometimes I add personal information about my life, and I expect you guys to be prepared to answer something so silly as, what was the name of my cat? Or what type of cat was he? He's an orange tabby cat. So I will see you guys later. Be prepared.